So what are we doing today? Okay, well, there, I'm going to move this over and I'll open the chat in case you guys have any questions, because I don't know if... Okay, I'll leave the chat open in case you guys have any questions along the way. Okay, so what we're doing is we're expanding upon what we did yesterday. Okay, it's just that physics is more than just the graphs, right? It's being able to actually like perform mathematical calculations and figure out things, right? That's what I'm going to show you today. And these things aren't going away. These are kind of cool equations. Like they're pretty applicable to what you're going to spend most of your time doing in physics, right? So I think my job here is to try to show you some tools and tips and tricks to kind of get you through how to navigate these questions. Okay. Now, right now, what we're dealing with, okay, for today, and what we'll see maybe Monday, I'll give you an introduction into something else. But for today, what we're going to be dealing with is typically like we're either going to see, and then I'm talking about this morning's lesson and this afternoon's lesson. We're only going to be dealing with questions that involve like trains going in the X direction only. Or this afternoon, what you'll see is vertical motion. So things traveling only in the Y. Okay, we're not mixing the two yet. That's for later. But what we're going to see is we're just applying these equations to situations like a train traveling this way or a car driving, right? They're only traveling in one dimension, like X, and they're accelerating and they have initial velocity and how far did they go, things like that. That's what the kind of questions we're going to ask, right? And so when I come down to number one, a subway train traveling west, okay, is brought to a rest in 10 seconds. Find the displacement of the train while it's coming to a stop. Okay, assume uniform deceleration. Okay, so that means your acceleration time graph would look like this. There wouldn't be any changes in the acceleration. Okay, so we're just going to get a number. It's just going to be a number that represents acceleration. Okay, so what we're going to do here, you need to write down. I wouldn't explicitly, like I'm past this stage. If you guys need this, you can. This graphs, but I use it inherently, right? To always. Right? It doesn't matter if I'm doing math questions or whatever. I always write down what I'm given and kind of what I'm looking for. And then my analysis piece here is like which equation am I going to select? Right? And then solution and statement. You don't need to write this down every time, but this is, I'm following this process, right? And so what you're going to do is I just make it a habit of writing down the things that I know right off the top. Well, okay. We've set up, or this question is being set up in a way where west, the train is, or the subway is traveling towards the west, right? And so we know what its initial velocity is, right? It's telling us that it's traveling at 20 meters per second, right? So VI is equal to 20 meters per second west. Now, it gives us another piece of information here. It's talking about seconds. Seconds always deals with time. So I also know delta t, the change in time in which something is occurring, is 10 seconds. Okay? And the thing that I'm after is the displacement. I'm after how far did the train travel before it comes to a complete stop. So there's one, a complete stop is another piece of key information there, right? You also know if it comes to a complete stop, then it's V final must be equal to 0 meters per second because it's come to complete stop, right? So just by writing down a very sequential series of like things that you know, you start unlocking pieces, and it guides your decision making as to which of these 5 equations you're going to select, right? And so we're like, okay, well, what's the thing that I'm looking for? I'm looking for delta D. Okay, that's what I'm looking for. Okay. And so what are you going to do? Well, which equation am I going to pick? Like, okay, so my initial thought is I could pick, I don't know, this one. Right? Because that looks like it has all the information that I need in it. Right? That's what you guys are trying to do. You're just trying to answer a question. What's D? Okay, well, let's just select that equation. D equals VI plus VF divided by 2. And multiply that by the time. So plug in your information. D equals VI, which we know to be 20 meters per second. Now, so at this point, I think you guys want to make a decision. You know that the train is traveling to the west. So when you get a final answer here of whatever your displacement is, distance traveled, you know that the train is traveling towards the west direction. So your answer better have an answer of west. Or if you choose not to do that, you can make this negative. Remember, we were talking about that yesterday. Right? We can make it west negative. You can plug in the negative 20 meters per second so that the sign spits itself out at the very end. Either way, it will work. Okay? You just got to keep it consistent. So we also know that VF is going to be 0 meters per second. Right? And we're going to divide that by 2 and then multiply by, how long did that take? 10 seconds. So we get 20 divided by 2 times 10. Which equals 200 divided by 2, which is equal to 100 meters. So therefore, it took the train 100 meters to stop. Right? It was traveling west, which we already kind of know. I suppose for this question, it doesn't matter too much. Okay, the sign just dictates which direction it's traveling in. Does anybody have any questions on how those things work out? Okay. You don't need to memorize those equations either. Okay. They're typically provided to any physics course you take. They're provided to you. Okay. So the second question. A sport utility vehicle with an initial velocity of 10 meters per second east accelerates. Okay, so we're speeding up here. So we're driving along at 10 meters per second. And if we accelerate at 5 meters per second squared, how long will it take for the SUV to acquire a final velocity of 25 meters per second east? So it's a lot of information in there. You like seeing lots of information. That makes your life easier, right? If you see less information, then you start to get a little bit scared, because then there's some other work. It's like these are the less information you have, the more work you're going to have to do. They're like two-step questions, right? Where you're going to have to solve for something else first and then find the other thing, right? So let's have a look here. A sport utility vehicle with an initial velocity of 10 meters per second east, right? So we know V1 equals 10 meters per second east. Right? We also know acceleration. It's going to be 5 meters per second squared. And it's accelerating in the east. So if it's accelerating in the same direction, right, you can see here, east and east, it means it's speeding up. If this was a west, then it would be slowing, it'd be putting the brakes on, it'd be slowing down. West. You might even see that this number is negative. Negative. And it's decelerating, which we saw that yesterday. The slope. Slope would have been negative. Okay? But it's accelerating because the acceleration is happening in the same direction that the object's moving in. So it's a speeding up, right? V2, we know, or V final. Sorry, you guys will see this too, and I put this in this afternoon's lesson. You can write V1 or V2, or you can write V, VI, and VF. I'm okay with both. Doesn't matter. They mean the same thing. Final velocity, initial velocity, V1, V2. Okay. So V2 here is going to be 25 meters per second. I'm interested in time. How long did this take? Right? So you're like, okay, let's pick an equation. You're like looking at the equations to say, okay, well, what do I have and what don't I have? Okay, well, we're like, okay, I've got V1, but and I've got V2, but here's the problem: I don't know distance, so I can't use that one. I mean, you could, but it's just harder to solve that way. So you want to pick the easiest solution that you can. All right? So like, okay, what about this one? Oh, it's got distance again. Don't want that one. What about this one? Well, it looks like that one's checking off all the stuff that I have and what I'm looking for. Right? So you know V final, or V2. V2 is equal to V1 plus A times T. Well, it looks like it checks everything off, and I'll be able to solve for T there. Right? So V2, we know, is 25, is equal to 10 plus, oh, what's it accelerating at? 5 times T. I say, okay, what am I going to do here? Well, you can create a zero pair here, right? You move the 10 over. You're going to get 15 is equal to 5T. Divide both sides by 5, and T will equal 3. So therefore, it will take 3 seconds for the vehicle Any questions? Relatively straightforward. Okay. Trying to see if I give you guys some harder questions for homework. I might have. Okay. The only way I can make these harder is by selecting which information I give you over here. Right? This is the key to kinematics. They don't get, there's only one more stage of difficulty to this, right? And it's when I selectively give you information such that you're gonna have to solve for the time first, like what we did here, and then pick another equation so that you've actually filled out enough information for one of these. In other words, there might be, based on the information given to you, you might be missing 2 pieces of information like B and A. So you might have to solve for one using one of the equations first, and then pick a different equation. That's the only way to make this more difficult. There's 2 stages, right? That's it. Sometimes it can be a bit tricky in terms of like, oh, what do I know? What don't I know? And then how do I arrive at my end result? That's the only thing that makes this harder. Okay, does anybody have any questions as I keep going? I'm just going to do 5 of them, and then you guys have some homework questions, and that's it, really. I just want to give you some practice. Like, oh, how do I use this equation? How do I manipulate these equations? Okay. A golf ball rolls up a steep hill. It's initially V1, 25 meters per second, and slows down an acceleration of slows down at that rate, and then find its displacement after 15 seconds. So it also tells us d is equal to 15, and we want to find its, t equals 15 seconds. We want to solve for what d is. Right, so you got what you're looking for, and conveniently it looks like a couple of these equations are already isolated for d, right? Now it doesn't tell us anything about the final velocity, so you're kind of stuck. Any of the ones that include the final velocity, you're kind of stuck using, right? You can't use them, right? Currently. So you're kind of looking at the rest of the equations trying to figure out, okay, well, what else could I use, right? Okay, well, I'm given d, or I'm looking for d. Okay, so that's that part. Vi, well, I know what Vi is, and I know what t is, and I know those two. Looks like that's a good equation to use. All right? You're just going through there. This is the thing I'm looking for, and then I know the whole right side. So, okay, d is equal to v1t plus half at squared, I believe. Yes. Okay, you just plug in your information. So d is going to equal v1, 25 times 15 plus 1/2 negative 5, 15 squared. You just type this into your calculator. You can do it in 2 pieces. Hopefully you guys got some of you got a scientific calculator. You can do it all in one go. Right? To bracket 25, close a bracket, 15, bracket plus 0.5 bracket times negative 5 times 15 squared. That's my answer. Yep. Okay. I don't know if you guys can see that or not. Maybe I hold it up to the screen. Can you guys see that? See what I did with the brackets? Bracket, bracket, bracket. Where'd it go? Okay. You just type it all in one line and then spit out a number, right? If you're on an iPhone calculator, which is kind of a pain, you're going to have to type these things individually, and it's a big mess, right? But it turns out that the distance here is negative 187.5 meters, right? So its displacement is, let me just see here. Why is that coming out negative? Let me make sense of this. Why? Why is it coming out to be negative? I might have to think about this one, guys. So you'll run into instances where you're like, and this is me checking my answer too, right, to make sure it makes sense. Might have to check into this one. I'm like, why is this number negative? Is my question. Does anybody have any ideas? Am I missing something? So I don't think the displacement, unless it's not, doesn't give us any form of direction though. So I suppose maybe the displacement could be in the negative direction, right? Like the where it's traveled. Yeah, the negative 5. Yeah, the negative. It's coming out negative because of that. It's decelerating, right? But there's no direction in the question, which is my issue. So I think maybe what's happened, what's missing from this question is the fact that we're moving in the negative direction, maybe. And then it's so whatever it is, south or whatever it is. Okay. It's displacement. Let me look into this one. The funny. I mean, like it's just, you're aware of, it's keeping you in check in terms of, maybe it did start rolling down the hill again. I don't know. Because it didn't say what its final velocity was. I don't know. I'll look into that one. Okay. It's interesting. But these are the sorts of things that like you guys are checking yourselves with, right? You're like, okay, well, it's negative. My answer makes sense. That's what's important. The most important thing, right? Like numerically and also from a direction standpoint, right? Like if you guys got like 158,000, right? Or whatever it would be. Like if you got a number like this, you got to question yourself. You got to look at stuff. Yeah, it would be decelerating, Megan. It's slowing down. Yeah, that's good. As so yesterday, Megan, we would have seen on the VT graph, had we seen on the velocity time graph that the slope was negative, this implied deceleration. Oh, it is slowing down. Okay, but I suppose the lesson that we can learn from this is numerically it kind of makes sense. I think numerically it kind of makes sense. The question is, why is this negative here? And we mathematically we know why it's there. But in terms of you guys get answers, you got to be able to like interpret them and make sure that like when you get a number, if you ever got a number like this for this question, you got to make sure that like something's wrong, right? And it's the exact same thing with the sign here. Like I know something funny is happening, or we're just missing the interpretation of something. Okay, and let me do some thinking on that one. Okay, but an important skill. You guys need to be able to identify when you're completely off basis, when your answer doesn't fit the context of the question. That's an important skill. Okay, and then try and rectify it. Figure out why. It's kind of physics. Because I can tell you right now, like a negative sign, when you guys get into more complicated questions and there might be 10 lines of solution, if you make a sign error in line 1, that's going to percolate its way through the whole solution. You're going to get to an answer and it's not going to make any sense. You're going to have to be able to identify where you've made a mistake. Okay? If you make mistakes, I don't know. Okay? I haven't seen any formatives yet. Okay? Let me look into number 3 there. Okay, so my car can accelerate from rest to 40 meters per second in exactly 30 meters. How long does it take to accelerate? Okay, so we're looking for time. Okay, so we know currently, right off the top, we know we're starting from rest. So we know V1 is going to equal 0. Okay, and then V2, it's asking us, okay, well, we want to get to that speed, so 40 meters per second. In exactly 30 meters. How long does this take? All right. Okay, well, which equation can I pick? I'll erase some stuff. It's not up there. It looks clean. You're like, okay, well, which equation is going to work best for me here? Well, it told me what distance was. All right, so we're okay with this. The ones with distance, anything with distance in it. It also told us what V1 and V2 were, and time. I'm kind of liking this one. It kind of looks like it's giving me all the information, right? Or I'm using all the information that's given to me in the question, right? So we're like, okay, well, D is equal to V1 plus V2 divided by 2 times T. Okay. Now, I'm just going to do this question a little bit differently because it's an important skill. And as we do bigger questions, you guys will thank yourselves later. I'm just going to try and push you guys towards solving questions in a particular way, right? Algebraically instead. Because what you'll find is like the more times you go to your calculator and you type in numbers and you're doing all these math step to step, it's going to take longer, first of all. Second of all, every time you type something into your calculator, if you get a decimal number, you're carrying rounding error. Third, maybe you make a mistake typing a number in. The more times you got to type things into your calculator, the higher the degree of, we'll say uncertainty, but like presence of error of some sort, rounding, human error, whatever it is, right? So if we can solve some questions, like just algebraically right off the top, and then plug in the numbers at the very end, you know, that's a faster way to do it, more efficient, and less likely to make an error, right? So what am I talking about? Okay, well, let's solve this question algebraically. Well, this one's kind of a little bit tricky mathematically to solve, right? But this is the same thing as saying we could go v1 plus v2. Both of those would be multiplied by t, right? If I were to multiply that in there. And then I'm also divided by 2. So I haven't really done anything. I've just kind of taken the first line and rewrote it. And that's equal to d, right? At this point, I'm just trying to get t by itself. Okay? And you say, okay, well, I can multiply both sides by 2. So you're going to get 2d is equal to v1 plus v2 times t. And you're like, okay, what's next? Well, I could divide both sides by, and sorry, I'm running into the next question. I could divide both sides by v1 plus v2, right? So I'd get an algebraic expression. I solved this with algebra, and I'd get an algebraic expression that said 2d divided by v1 plus v2, that's equal to t. So if that's the thing I'm interested in, how long did this take? I now have an algebraic expression because I've manipulated what was originally given to me, right, to solve for it. And now all the things that I'm given are all things that I could just plug directly into this equation that I've just isolated myself for, right? This is going to be an important skill as we do more complicated questions, being able to take something, maybe you don't have a numerical number, right, for something. But if you work through the process of solving this question algebraically, sometimes things like the big one, mass, which we'll see later, ends up canceling, and you don't need to know what mass is. It's independent. It doesn't matter. Irrelevant, right? And we can see that in some of the ways when we solve things algebraically. So now, you're at the stage now where we can say, okay, well, t is equal to 2 times 30 divided by v1 plus v2. Well, v1 was 0 plus 40. And what are you going to get? You're going to get 60 over 40. So the time is going to be equal to, be 2/3, right? Or, sorry, not 2/3. Close to 1.5. 1.5. Be 2/3 if it was the other way. Good, that's the answer I got. Do we have any questions? There's nothing wrong with, as you guys getting into physics for the very first time, right? You're going to go through a stage where this is very comfortable for you, where I take things like my velocity and I substitute, and I take this and I plug it into there, and I take the d value and I plug it in, and then I type things into my calculator. That's being comfortable, right? And there will be a stage where you guys need to do that. Right, but there's also a stage of this course and into grade 12 where you're going to need to be able to take something that's given to you, like an equation, or create some sort of situation, which we'll see in the second unit, and work with things with just letters. Okay, we need to be able to do some algebra. It can't all be type things into the calculator. That's not all of physics, right? Because sometimes you don't know what things are. And so if you think back to day 1, when we had like a substitution elimination questions, right, that I asked you guys to look at, in that instance, you solved those things algebraically. You had no idea what a and t were going to be, or x and y. You guys have these skills, right, where you've worked with algebra. You write something in terms of something else. That's what we did here. We took something and wrote it in terms of something else, and we're able to solve, right? There will be instances where we don't know two things, and we gotta be able to work with that. Okay, so I'm not gonna force you to do this, but right now, hopefully by the end of the course, you guys have your math skills, and like you build your math skills up to the point that you're able to do this a little bit more quickly, right? And you'll see, in particular, electricity or some of the big gravity questions when we have scientific notation. Like, you guys don't want to sit into the calculator and type in 9 times 10 to the 9 times 2 times 10 to the negative 3. Like, you don't want to sit there and type that in like 4 times in a question. You'd rather just do it at the very end and be done with it, right? For the exact reasons that I was talking about. You're going to get rounding. You're going to get, you might mess up typing in a 0 or a scientific notation. You're going to get a wrong answer. And that's nearly impossible to find. You're going to have to restart the question and go through it to find where you've mistyped something into the calculator. That's annoying. Right? So what I'm trying to do is, like, here's an introduction. You guys can play around with this stuff today. You know, throw some numbers into some equations, but try to get yourself away from, like, typing into the calculator. Okay, it's a calculators give you the answer at the very end. Okay, and that you prevent yourself from creating rounding errors and things like that. Okay, so a skier, we'll do one more, and then that'll be it. Okay, so a skier moving down a uniform slope at 2 meters per second. Right, so v1 2 meters per second. Oops, 2 meters per second. They accelerate. A is 3. And find the skier's displacement after 6 seconds. So we also know delta t is 6 seconds, and we want to find delta t, or how far they've traveled. Okay, you're like, okay, let's pick an equation. This one kind of looks good. Okay, we're like, okay, well, d equals v1t plus half at squared. Okay, this is kind of nice because it's already isolated, so all this conversation we just had about this stuff here, algebra, out the window for this question because you already have something isolated. Well, that's nice. You like situations where that happens. But what happens if I asked you for the acceleration? You'd have to, I would untie this using some algebra and get something a equals all of this. That's what I mean. Okay. It's completely around what you're asked for. Okay, so we can just solve this now. So we know d is going to equal to 2 times 3. Nope, not 3. 6 plus 1/2 of 3 times 6 squared. Okay, so you're going to get d equals 12 plus 1/2 of 3 times 36. And sometimes, you guys, I'll do this. I'll just try doing things like in a way that maybe you guys don't need calculators, right? I don't know. D equals 12. Like, I'll just show you some math tricks that I'm kind of using in my head. Plus 3 times 18. Did we see where that came from? Half of 36 is 18. 3 times 18 is 54. I think. I'll make sure so we don't get a wrong answer. Yes, I'm right. And then so d equals 12 plus 54. Well, 54 and 10 is 64, and 2 will be 66 meters. Boom. Is everybody okay? Am I freaking out? Okay, like I said, this is it's yeah. I'm glad Chase is making sense. Like I give you all 5 equations, like you'll be given those. I think if you guys, I tried to model here in the way that you spell everything out. Yeah, you guys are going to do more equations and graphs. The graphs are just a little small portion of stuff. Okay, but you have to, there'll be, so for instance, I'll give you a little story about university for me. First year university went something like this. Your mark breakdown is like I was in first year physics, right? And they don't really, like I'd say probably 60% of my program was done by Thanksgiving, right? Like people were gone, just dropping like crazy, just disappearing, going home, going back to, or switching to different programs, right?